Hey everyone, let us jump right in and clear up a massive misunderstanding in the database world. A lot of older engineers look at modern graph databases and say, wait a minute. Didn't we already try this back in the 1970s with the network model? The answer is absolutely not. They look similar on the surface, but they are completely different beasts under the hood. Here is why the old 1970s network model failed, and why modern graphs succeed. In the 70s, your database had incredibly strict rules, called a schema. You could not just connect things randomly. If you wanted to find data, you literally had to write imperative computer code to manually drive your way through a confusing maze of hard drive pointers. It was a nightmare. Today, modern graph databases have zero strict rules. Any node can connect to literally any other node on the fly. Furthermore, you do not have to walk through a maze. You can teleport directly to any piece of data using its ID. And best of all, you use a declarative query language. You just tell the computer what you want, and the query optimizer solves the maze for you automatically. It is a totally different world. Alright, let us shift gears and talk about something called a triple store. A triple store sounds incredibly complicated and fancy, but it is actually wonderfully simple. A triple store is literally just a graph database wearing a different hat. It uses different words, but does the exact same thing. In a triple store, absolutely all the information in the database is broken down into tiny, three-part sentences. Look at the diagram on the screen. The sentence consists of a subject, a predicate, and an object. Let us look at the code examples. In example 1, we want to connect two nodes together. We just write the triple, Jim likes bananas. Jim is the subject, likes is the verb, or the predicate, and bananas is the object. It perfectly maps to a graph, where Jim and bananas are the nodes, and the word likes is the edge connecting them. In example 2, we use a triple to just set a simple property. We write, Lucy, age 33. By storing millions of these tiny three-part sentences, we can build a massive, highly detailed web of knowledge. Now, if you start reading articles about triple stores, you will immediately get sucked into crazy stories about something called the Semantic Web. Back in the early 2000s, engineers had a wild idea. They said, look, websites publish text and pictures for human eyeballs to read. What if websites also published invisible, structured data specifically for computers to read? The grand goal of the Semantic Web was to link every website together, turning the entire internet into one massive, global database of knowledge. To make a global internet database work, everyone on Earth had to agree on a single format. They chose the triple store format and called it RDF, which stands for Resource Description Framework. Ultimately, the Semantic Web was massively overhyped, and the global internet project failed. People became very cynical about it. However, If we ignore the failure of the internet-wide project, the RDF triple store technology they created is actually brilliant. And developers still use it to build incredibly powerful internal databases today. So, if we build a triple store database, how do we write code to search it? We use a beautiful query language called SPARQL. It is pronounced exactly like the word SPARQL. It is actually older than the cipher language we learned about earlier. And they look very similar. Look at the code box. In SPARQL, we use a question mark to create a variable. So, we say, select question mark person name. Then, inside the brackets, we lay out our triples. We are telling the database to find any person who was born in a location within the United States and who currently lives in a location within Europe. It is incredibly clean, declarative code. And with that, we have officially covered everything you need to know about modern data models. I highly recommend taking a break, drinking some water, and letting all these concepts sink in. You guys are doing great. And I will catch you in the next one.